First thing we said, all galaxies have gas. Second thing we said that gas is spread more than stars. Third thing, obviously you should be already thinking. Here, when I look at light, these three are not at all connected. When I look at gas, you see they are all connected. That means if I bring two galaxies close to each other, the gas will start flowing from one to another. Okay? So this you understand. So it's like our electricity hidden in our house building. Now we say that whenever you talk about galaxy, you don't talk only about stars, because stars will tell you something, but you have to worry about gas also, because gas is going to tell something about that galaxy, as well as whether the galaxy is a quiet person or it is interacting with everybody in the surrounding region. Okay? So the analogy is, now we know the structure will come from star. We said electricity will come from, equivalent of that is that you need to have gas. Okay? This is what it is. So we understood we need gas to form a galaxy, and we need stars to form a galaxy. Of course, there is a quick detour we can take. If you ask what is a star? Star is nothing but a gas ball. Okay? In fact, you will be surprised, this is the joke people would have told you. If you take the average density means mass per unit volume. If you take average density of any star like sun, that is like our water. So you might be hearing this in some colloquial thing. Suppose you have a huge amount of water present somewhere, and if you put our sun in that water, will it go inside or float? You will be surprised, it will float. The sun is so massive, still it will float. So you understand. So this is very interesting problem. So sun or stars are made of gas. So gas and stars are part of each other. Okay, we have to remember that. So that's what galaxy means. There are stars and there are gas. Of course, you have to remember the stars you see comes from this gas. Okay, so it's a simple. Let me see whether it works. Otherwise, I'll just. So this is the same picture. If you take a deeper image, now you see that the same three galaxies, they are now well connected. So this is the point I have already proved. So you are with me, right? Next point we want to do is, I just wanted to show a small movie of one of these galaxies. If you go and look at in much more detail, you find something interesting. What is interesting here is that this is your galaxy, but if you map the gas very carefully, you will find that the galaxy throw huge amount of matter in. It's like our fountain now, pani, so whatever, water fountain. Like that, most of the galaxies have this kind of fountains. The gas just goes from inside to outside. Okay, it's a large. So let's repeat. To form a galaxy, I need lots of stars, lots of gas. If I put two galaxies together, gas will tell me how they are interacting. But individual galaxies themselves sometimes can throw gas to large distances like we do. It's again, घर में पानी pipe फट गया तो you will have fountains going there also. So this is the kind of thing you have to remember. The next thing which is interesting for us is that we have looked at the galaxies, we have looked at the gas. Now you can ask what this gas is doing, right? You will be interested in knowing this. Now I cannot jump from this floor. You know that I cannot float here. Why? I am under the gravity. So if I put too much stars there and I put gas there, how gas can stay like this? It will be attracted by gravity, it should fall. Okay? If I don't want to fall into the center, what should I do? I should have a force which is in the opposite direction. Okay? How will you naturally produce this force? And you have studied something called centripetal and centrifugal motions. So if I have a mass here, if I put another mass here, I don't do anything, it will be attracted towards this. But instead of leaving it like this, I make it go around with proper speed, then what happens? This this particle will gain another force which will be outward going because of the motion in the circle. So if you put anything going around circle, it will not fall into the center. The way to understand is that every time it is falling, but the motion is taking you forward. This is the way we walk. Okay? If I don't do anything, I will fall. But I am not falling because this leg is supporting me. I am going like this. Our walk is a continuous fall towards earth, supported by our leg. Exactly like this, going around an object is a continuous fall into the center, but the fall is supported by the fact that you have enough force which will make it go around the circle. Okay? So the same thing will happen to the gas. If I look at a galaxy, now if I see that all gas particles have nice shape, the shape is not changing. That means what will you conclude? The gas cannot be stable. If it was stable, they would have fallen into the center. Fact that it is not stable, it is rotating around. Okay? This is the first important point we learn, is that gas, if it has to be distributed to large distance, it has to have a motion going around the central regions where the stars are there. So now I want some questions also. This is exactly what is happening in planets. Yeah.
So gas is orbiting it.
That's what I am telling. Yeah. So let's take this example of sun and our planet. What happened to our planet? Different planets are there. They don't fall into the sun because they are going around. Do you know what is the speed at which different planets move? Which goes around faster? Huh? Mercury. Which is slowest? Pluto. Okay. You will not say Neptune. Pluto, we don't know whether it's a planet or not. Okay. So what do you understand from there? If there is a mass, if there is a single mass, and if the particles are going around the mass, as the distance increases, velocity will decrease or increase? I don't know. How many people say decrease? Only one. How many people say increase? I'm sorry, it is to decrease. Because what is the gravitational force? Newton's law, you remember, na? G m by r. If r is more, it is in the denominator, so velocity will go down. Okay? So this is what is expected. So what we can do is that we can go and check in the galaxy whether the velocities are increasing or decreasing or constant. So this is what is done here. So take a galaxy here, you go to the center and keep on looking at gas here. The gas is rotating like this now. For this galaxy is like this, gas is rotating like this. So you can go to each point and calculate the speed at which the particles are rotating. This we can do observationally through some effect known as Doppler effect. I will not explain now, but you believe me, we can measure velocities. Once you do this, what people are finding, what we said in our planetary system, is that as you go further, this is velocity along the distance, as you go further, the velocity keeps decreasing. This is what we have found in our system. Okay? That is because of what? Newton's law says that G m by r. Okay? R is in the denominator, m is not changing. Okay? But what you measure in a galaxy, if you take a typical galaxy, what you measure is that velocity as you go further and further and further and further, the velocity is not at all changing. It remains constant. Okay? So you are with me now. Observationally what you see, velocity remains constant. But what you are expecting from our Newton's law, velocity should fall, decrease. So this is a problem. How do you solve it? So now take the same equation. Equation is what? Mass divided by radius. Mass is in the numerator, radius in the denominator. Why the velocity is falling when you go to large distance? Mass remains same, distances keep on increasing. Okay? Numerator remains same, denominator is increasing, the ratio will decrease. Correct? So if I want to keep the ratio constant, what should I do? I go to larger and larger distance. Distance anyway, numerator is changing. if I want to keep the same equation, if I want to say Newton is correct, how will I do it? I have to assume mass is not constant. As you go further and further and further and further out, masses keep on increasing. This I have to make an assumption. Okay? So let's do this exercise in an understandable way. If I ask all of you to come and somehow manage in the stage, I ask you what is the mass of all of us put together. That will be mass of people who are sitting in this stage. Now I say that you go back and sit all over the place. Now I ask you, what is the mass up to row 1? What is the mass up to row 2? That means I will get back the same original mass which I talked about in the beginning when I ask you what is the mass up to the last boundary wall. This mass will keep on increasing. This is what you have to imagine. This is the distance I am going to tell you. The distance keep on increasing, mass will keep on increase because I am going to add more and more rows into it. Other way of saying is, in the case of star, what happened? All the mass is in the star and planets don't add mass to it. Planet mass is much, much less compared to stars. So when you are writing down how planets will move, you take mass of sun and the distance of the planet from the sun to decide what is the speed at which will go. Galaxies are like this room. If I am at a radius r, I should worry about how much stars are there within that radius r. Like the way I said, if I go to row number 5, if I ask you how many people are there inside me, I can count only people sitting in the first 5 rows. You understand? If I go to the last row, I will count all of your thing. So this is exactly what happened. Galaxies are distributed like this. Stars are smoothly distributed. If I am at some radius, I should worry about all the stars within that radius. If I go further and further and further and further out, I have to keep adding masses which are inside. So this is an interesting problem. So if you believe in Newton's law, this is what you have to do. Okay? The fact that rotation outside is remaining constant means that as I keep going outside, as I keep increasing my radius, my mass is also increasing. This is a very interesting problem, right? And I see galaxy of this size. I go to sizes bigger than, because gas is distributed to larger sizes, right? I go to larger and larger distance, still I find that mass keep on increasing. This is the puzzle. Where this mass is coming from? Okay? So this question is interesting problem. I just demonstrate it with a movie if it works. So here there are two things we are doing, and here all the mass is in the center. This is the movie we created like that, right? All the mass is in the center. So now look at how the gas is going around, and you can see this gas particle is moving slower compared to gas particle in this model. This is what you have to look at. Sorry. I will play it again. Just look at this is going very fast, right? This gas is moving fast here compared to this. What is the difference between these two? Here we said that all the mass is in the center. Here we said that mass is distributed like the way we are distributed in this room. Okay? So what this has led to? This has led to the conclusion that every galaxy, you have something else. You have star, you have gas. These two are not sufficient to explain what we are seeing here. We have to introduce one more component, like our pipe. We said water pipe you have put, now electricity line you have to put. That is called dark matter. So what is dark matter? How do you found there is requirement for dark matter? We are seeing galaxies are rotating faster than what you expect them to rotate at the larger distances. If you really want to keep them rotating, I need to have mass which is distributed the way I was explaining to you. Mass should be there everywhere. Everywhere I go, I have to have mass. But the stars are not like that. Stars are located in whatever we see with our eye. So people conclude now that at largest distances, what you need is that you need dark matter. Okay? So now, if you don't understand, you go back and read a bit more about this, or I can explain to you. I can send you some references if you write to me. Okay? So now let's recollect. If I ask you to form a galaxy, what are the things you want? First thing you say that I need hundreds of billions of stars. Second thing, I need that with the stars, I need lots of gas. Third thing now we have understood is that these two are useless. I need to have dark matter into which this gas will be rotating, right? How gas rotates will be decided by the dark matter. That means who is the big boss there? It is exactly like big boss house. You don't see the person in the house, but the person controls everybody. Correct? You have seen, I don't advise you to see the big boss, but this is the program which you see, right? Everybody moving in the house, controlled by the voice which is from outside. That voice in this problem is dark matter. Okay? So are we set now? Are we set? We know that whatever we want dark matter, we want gas, we want star. Are we set? No. This is a problem. Okay? Let's see one more movie. If it runs. So we are basically zooming into the center of our galaxy. Okay? So this is the galactic center. So we are just going deeper and deeper, and I will wait for some time. See, now so many stars are there, na? That's why now we are almost reaching the center of the galaxy, our Milky Way, and we are going at higher resolution. Just imagine you are zooming into this. Now we started seeing individual stars, right? Each dot is a star now, because you are no more seeing the galaxy like this. Now you see this individual star, what they do. Stars move around somewhere. Now you just see there is these stars are going around like this. If I put a dot here, you see all the stars move around that dot. Okay? This is almost like our planets moving around something. So you know Kepler's law. So if you go to the central region of our galaxy, just to zoom in, look at the star, you take a picture today, you take the picture tomorrow, you keep on taking the picture for years together. That's what is being done here. Then you see the stars just move around like that. Okay? Now you can see how the motion, you can now track the trajectory of each star. In fact, it is puzzling. When you go to the center of the galaxy, it behaves like what happens to us. We take sun, some of them are going around, some of them can come and go. We have seen this whatever. Okay, so I should not advertise too much, so we'll move to the this is the problem in taking from YouTube. Okay, so what we have found is that in the central, you notice that central regions are behaving like this. There are some stars which behave like comet. They go like this, go to the center and get reflected and go away. Some of them are trapped like that. So now what you can do is that you can go there and apply the same law which you use. What is Kepler's law? That's what we use, right? Kepler's law is what is used to understand the motion of planets around sun. The same law you can use. Then you ask, suppose if the star has to move like this, what should be there in the center? You don't see it. So this is what is called black hole. What is the mass of this black hole? It is anywhere between 1 crore to 10 crore suns. You take 1 crore suns, in the sense that you take that many sun-like stars, put them into a smallest region. So what is the size you have to put? The size you have to put is between Sun and Venus. It is smaller than between Sun and Venus. That is the kind of size you have. But how many stars you are going to put? In our galaxy, you will put about 5 crore stars. Imagine 5 crore stars into that region. So that is what is called black hole. And then you will say that, okay, is it important? It is such a small thing, right? Means like 10 to the 5 crore is nothing but 100 billion. 5 crore you can ignore. Is compared to the full number of stars, it is a small amount you can leave. But the most important thing what you find is that in the centers of our galaxy, there is something which is very massive and very small radius. So this is called black hole. We call them as black hole. The question is this black hole only in our galaxy? This is like kitchen, right? It's like every house should have a kitchen. Some people may not cook, but still kitchen will be there. Okay. So an engine or a resource is like this. So now people know that there are black holes not only in our galaxy. We can detect black holes in every galaxy. Wherever you go and search, you find black holes in every galaxy. So what we should do? Now ask a question again. What is a galaxy? We'll start from beginning. Galaxy has a star. It has gas. They are all living in a dark matter, and they should also have a black hole in the center. Okay. Okay, it is easy now. I can just it's like a contractor. You say, buy a black hole from somewhere, buy dark matter from somewhere, buy gas from somewhere, star from somewhere, put together in one place. Is it like that? No. Problem is, stars are formed from the gas. So the gas is needed to form a star. So that is the problem. We have to start with something, right? We have to start with something, and then we have to build this thing together. So another problem we are facing, okay, I just to show one of those slides. Another problem people found is that you go and measure the mass of the black hole, how massive the black hole is, how many equivalent of stars are there. What one finds is that if you take a very big galaxy, the black hole is massive. When you take a smaller galaxy, black hole is smaller only, less massive. Low mass in small galaxy, high mass in big galaxy. This is an interesting puzzle. Why it is puzzle? I told you the distance we will worry about when you are talking about black hole is the distance between our sun and Venus, or one of those nearest thing. It's so small, which in numbers is 10 to the power 12. That means 1 followed by 12 zeros. Whereas if you look at the size of the galaxy where you are finding the mass, that is 1 followed by 21 zeros. You understand? When you are talking about black hole, the distance you will be worried about is 1 followed by 12 zeros. When you are talking about galaxy, it's 1 followed by 22 zeros, actually 3 times 10 to the 21, okay, 22. So that means these sizes are like the scales of, it's like saying that human being has some size and the earth has some size. Will you be able to control the earth? Yes, na? Because you cannot control the earth by certain things, but you can control the earth by putting a nuclear bomb. Okay? So that means you can control the smallest region, can control the largest region by doing lot of high energy activities like nuclear bombs. Okay? This is what you have to remember. But what observations tell us is that this is what is needed in the galaxy. The black hole knows which galaxy it is living, and the galaxy knows how much mass a black hole should have. Okay? Let's build our problem again. I want to start, I'm going to be physics-wise what it is. I want to have a region with large number of dark matter. That region should have gas also. I should be able to convert this gas into star so that I will call it as a galaxy. Okay? So galaxy component is what? I have dark matter. I'm going ulta now. I have dark matter, I have gas, I have stars. But in addition to that, I should have a black hole. And how much black hole I am going to grow will be decided by what kind of thing I am starting with. So it is very interesting. This problem of building is slightly different from problem of building our house. When I said building our house, it is not that the process of building the wall will decide what is the process of tubes which will allow water to flow and what is the process of wires which will allow current to grow. It's not like that. We have to have one process which will build everything from scratch. Okay? So this is the difficulty. What is the second difficulty? Second difficulty is that here you have full control. You can decide who is the contractor, which color you have to paint. In space, you have no control. You cannot go and change the star. Na? Even I cannot say that I don't like this sun, change it to something else. We can do it in our house. But here we cannot do. That means nature has to create it starting from some basic idea. So this is what we are after. So how does one do? Of course, you can, I I start with one question, that is, I think you understood the problem related to forming a galaxy. Now there is a bigger problem. When we are discussing about whatever you call our address, we stopped with Milky Way. But it didn't stop there. Milky Way galaxy is part of what we call local group of galaxies. If we take local group, it is part of a cluster. If we take a cluster, it is part of some bigger one. So if you look at all the galaxies in our universe, and each one of them is plotted like a dot, this is what is the kind of distribution you will see. That means galaxies are there everywhere. It is not that galaxies are there only we live in a galaxy. Okay? Galaxies are spread all over the place. So the problem becomes a bigger issue. Problem of forming a galaxy is not just related to forming one galaxy. I have to form the full city. It's not building one house. We are forming the full city, and all should come from the same physics. Correct? It's not like our lab. We cannot go and dictate something. But what do you see here? This is the last thing I wanted to spend some time on. If I look at the dots, this is the distance. This axis is distance. So I just, as if I am observing like this at different distances, when I find a galaxy, I'll just put a dot. Are these dots uniformly distributed? No, right? Somewhere you find there are more dots. Somewhere you find there are no dots. Okay? This is the problem. The second problem we are going to face is that, okay, you know how to form a galaxy. You will tell me, give me dark matter, give me stars, give me gas, give me black hole. I will give you a galaxy. But the problem is I am not worried about one galaxy. I have to produce billions of galaxies. So that's the problem. When I produce billions of galaxies, you can say, oh, okay, produce it wherever you want. Apparently the nature is not like that. Nature does something peculiar. In some region it forms more galaxies. In some region it doesn't form galaxies at all. It's interesting. So we have to do this. So if you are forming one galaxy, it is not sufficient to form one galaxy. We have to decide how many galaxies I am going to form, and how I am going to form, and how I am going to distribute. And this is visible in the sky, and you have to reproduce. Are you with me now, till now? Okay? We have logically built a problem of what is known as structure formation. You have to form the grand universe. Grand universe should have galaxies. Each galaxy, what they should have, we know. We also know how the galaxies are distributed. How do you do it? It's amazing. Actually, sometimes you will be completely surprised how physics is so simple. In fact, this is a complex problem, but the whole thing can be visualized. I will show you from now on. You can visualize these things without doing too many fancy physics. Okay? So just to do that, I have to skip few. I will come back if there is time. Okay? Okay, so how do you do it? So imagine this is the thing I am going to say. This is the kind of simulation. Now forget about whatever we discussed. Whatever I told, I should put it in a computer and make sure that this computer is producing what I want. So computers are limited. Even though you can have supercomputers, they cannot produce the whole world. So what we will do is that we will make a computer like our universe is a small box. Okay? Small box means the sizes are very large. Each size is like 1 followed by 25 ciphers or zeros. Okay? So that is the length we have, and kilometers, you see it's huge. We can't imagine how much light years and all, right? You can think of like billions of light years is the size. So each size is like this. And each dot is a randomly distributed particles. Only thing we are going to do is that these particles are going to attract towards each other by gravity. Okay? You leave the particle, what will happen? Every particle will attract another particle. If two particles come together, they become stronger, they will attract more particle towards that. But if you just leave it, all particles will go to the center, right? Because gravity is attractive, it will keep attracting all of them. But what do we know? Do you know what is our universe? Do you hear about Big Bang? What is Big Bang? Expanding. Okay? So we have to do this problem in an interesting way. How am I going to do these particles to form a galaxy? I will collect the particles into a smaller region so that they will appear like a galaxy. So I have to bring them together. What will bring them together is gravity. Correct? But what is the problem? I know universe is expanding. What universe will do? Universe will try to push each particle away from each other, whereas the gravity will try to push particle towards each other. That means in some places your universe will win, that means particles will go away from each other. In some places gravity will win, particles come towards each other. This simply explains why in some regions there are more galaxies, why in some regions there are less galaxies. Places where gravity wins, you will have more galaxies. Places where the expansion wins, you will have less galaxies. Okay? These more galaxies are called clusters, less galaxies are called voids. Okay? You just remember voids and clusters. So I will just play this movie. And you can see nothing is done, it's Newton's law. You are just applying Newton's law, and suddenly you see in this small box, you start with, क्या हो गया? What happened? Why is this unrest? Any confusion? Huh? So you don't understand anything, or is there any problem? Yeah? No, that is time. You can think of like, this is like time. This you can think of like, when it becomes 0, that is today. Okay? When it becomes, this number becomes 0, that is today. And this number is telling you the rate at which our universe is expanding. I will not go into this. But imagine as if we start with some time t, by the time this become equal to 0, that is 13 billion years. Okay? That's what you have to remember. I should have made it, I have taken it from some other resource, so I didn't put it in time, but I can put the time stamp next time. Thank you. So I'll just replay it. We start from uniform thing, but by the time this becomes 0, that means by the time we are close to present day 13 billion years, and you find that already you have the structures. This is no more uniform, and you see regions where there are more galaxies. Each one you can think of like a galaxy, and then you have regions which are wide. That means the largest distribution what we are seeing is well reproduced now. We understand you have to start with some kind of uniform universe with some small fluctuations you give, and that can attract, particles can get attracted towards each other. There are two forces acting on all the particles in the universe. One is the gravity between different particles. Second thing is the expansion of the universe. Expansion will try to make the particle go away. Gravity will make them come towards each other. And what we have found is that in this setting, if you just allow the universe to peacefully go through its evolution, you will find that you can produce structures. Second question is that can you produce elliptical galaxies? What is required to produce elliptical galaxies or spiral galaxies? I will just show some examples. This is just to show that in principle we understand physics behind this. These are not real, right? So you can actually, okay, I should stop this guy. Wait a minute, I'll have to do this. And you can just see this is what is. There are individual parts are all galaxies, small galaxies which are formed. This is time is changing, okay? And you can understand the grand spiral we see how it is evolved in a numerical simulation. There are small galaxies here. With respect to time, they are all attracted towards this. You see, they are moving slowly. We don't visualize, but you can clearly see these guys are all locally, they are merging, they are becoming bigger. Each one of them is becoming bigger locally, but they are all moving towards some central regions where something interesting is going to happen. You just see. You see now, these two will join to become one. All of them have become one here. You already see. Okay. So this mergers. Interesting thing is that in these models, we start with dark matter, you form stars, you have gas. All of them are there. Whatever we discussed, they are all produced, because if I want to explain all this, I need one more lecture. I will not go into this. But you can clearly see we started with something, but now all of them are going to get into the central, and you will find a grand galaxy being produced. Now you see this. So the single galaxy you see today is built like this. That's the point. Okay. I should have put some music so that you would have been quiet. Okay, you see this. So the point we want to see is we started with a simple idea, simple idea of forming galaxy, and you are seeing the galaxy, and we say that if you are going to form galaxy, you are not worried about forming one galaxy. You should form large number of galaxies, and they should be distributed in a particular way. In some place, there will be lot of them. In some other place, there will be nothing, kind of. When you produce this thing, just to see what happened to individual galaxy. This is beautiful galaxy, right? You see, this is like what picture you are seeing today. But it started, if you start how this whole thing is there in a simulation, you start billions years back, a single galaxy is formed by large number of small galaxies. First you form small galaxies, they get attracted towards each other, and I gave you an example of when two galaxies come close to each other, they interact. How do they interact? We have seen it in the form of gas being thrown all over the place or connected these galaxies. So this is what one has to be worried about. Okay, we have to worry about forming galaxy means like a individual galaxy is not like one galaxy I have formed. It's not, again, this is once again it removes my analogy. I form a house means we don't form a house like that. Okay, we form one house, that's it. Here galaxies are not like house. Today it is like this, tomorrow this big galaxy will go into another galaxy. Okay? So today it looks like big, it will become even bigger by moving into some other galaxy. So this is what is known as hierarchical formation of galaxies. So if you form one galaxy, your question is not forming one galaxy, question is forming several galaxies, they become one. Okay? So this is why process become very difficult for you to actually do it by hand. It's not physics where you write down equations and solve. You cannot do it because we have to worry about all the kind of things going around you to get this. Okay, you are with me till now? Okay, this is the same kind of thing, I will skip. So I'll just see, for example, people even went around and formed our own galaxy, Milky Way. You can just see the movie of how our galaxy was formed. Again, it looks like this is our galaxy, right? This is the center. But do you see things are forming in a line? So now what you are seeing, we are going into one galaxy and asking what happens here. And did you see these things, matter coming in? And now we have these spirals, exactly like the way we see. We can produce them. Okay? So the purpose of showing this movie is in the beginning. You can keep seeing that even after a galaxy is formed, you see matter keeps coming in and keep adding mass to it. Okay. So this is what I wanted to conclude. What I want to conclude is that we understand what you want. So let me summarize from the beginning, right? Because you are getting restless, I am also getting tired, so we should stop at some stage. What are the galaxies? Now your definition is going to change. Galaxy means galaxy should have stars, gas, dark matter and black hole. But how are we going to form? It is not very clear to me. A single galaxy is a collection of large number of galaxies which are present all over the place. So if I want to decide one galaxy, I have to worry about the surrounding regions from which how many galaxies I can form which can get into one galaxy. Okay? So that is the problem which we are doing. And this problem of why we have to solve this, because this is very important. Because how many galaxies I will have in my universe depends on what is the initial condition I am starting with. If you believe in Big Bang, you will come with one particular prediction. If you believe in some other model, you will come up with some other prediction. So if you want to test your model, you should be able to produce these galaxies and just go out and observe them and see what you are seeing. The kind of simulation I have shown, will you be able to observe them? Yes, we are making these observations. This is why I have few slides, but I don't have time. This is why one is interested in what is known as James Webb Telescope. James Webb Telescope is actually seeing these kind of things. The small galaxies with black hole, it is already seeing, and since it is looking at very deep in the universe, you can actually map how galaxies come together, how they are merging and things like that. So what can we do here? So this requires high performance computers. Computers which are supercomputers only will be producing. I just show examples. So till now whatever I have been showing are movies and other things were run by various people all over the world for which the links are given. But I just wanted to show that in IUCAA we can do this also. Now we have set up a supercomputer here where you will be able to do this. I just to show you a small slice of same exercise, and you see that this is a small slice. Each particle is a galaxy. Now I can take this smaller box and put it, this is what is zoomed in, and you can see these small galaxies are there. I take this zoom in, this is what it is. Okay, so we can produce them, and just see how nice these galaxies are. These are not from observations. Okay, these are the ones which we have produced in our laboratories. So I will stop here, and if you have any questions, I will be happy to answer. Wait.
So yes, you'll be taking few questions now. We can see that sir has even come up with this complex topic and explained in a simple way. So most of the questions are welcome. Yeah.
Bolo.
Please listen to the questions carefully.
Do galaxies collide?
Bolo.
Do galaxies collide?
Yes, I showed you. Yeah, they collide. That's how biggest galaxies are formed by collision of large number of small galaxies. This is what the movie was showing. The collision is always happens. Yeah.
Just a second. Everyone, students, I want all of you to be quiet for 10 minutes at least. We'll be taking only few questions. And please keep your hand raised, and we have Saurabh and Srianand coming with the mic. But we want everyone to listen to the question carefully because most of you are talking and we are not able to concentrate on that. Yes, yes, who is the next one? Yes, please.
So my question is that in one of the slides, it was like some yellow particles, they were coming together to form a galaxy. So these yellow particles are stars, gases and other things, or other galaxies making a whole?
It's a good point, but in the simulation we just put particles. Okay, what you are seeing is particles, and that yellow color particle was dark matter particle, whereas the later on simulation whatever I showed different color, yellow is star and the blue is I think if you go to this slide, just to show you, in this one yellows are star and the blue color you are seeing is the dark matter. The galaxies are made of, all galaxies will have stars and dark matter, and the galaxies can eat another galaxy nearby. There is no problem.
So during the expansion of a galaxy, is it to a finite limit? And if there is
Sorry, I am unable to hear. Can you please keep quiet?
during the expansion of a galaxy, is it to a finite limit? And if there is a limit, how is it determined?
No, galaxy will not expand. So you just remember what we said. Suppose if I have some particle, there are two things which are going to happen, right? One is that particles are trying to expand because of expansion of the universe. No, I'm not going to answer if you are not going to keep quiet.
Yes, everyone, if you keep talking, you will be staying longer here.
Can you please keep quiet?
Please be quiet.
Okay. So whenever particles are attracted by gravity, then only galaxy can form. Okay. Once you form galaxy, those particles will not be expanding.
So, as we know that gas is not stable, so how can it be arranged in a uniform motion in spiral galaxies?
No, gas is not stable, but it's like this, now. See, you can. I can ask you some simple questions. See, for example, if somebody goes to space and take a photo between Pune and Pune and Mumbai, they take a photo, they will see the light in the Pune-Mumbai highway, where there will be maximum light. Maximum light will be there around the toll, because in all other places cars are going, Around the toll, cars are going to be staying there. That is where maximum number of cars, each one will be touching each other. The headlight will be visible. But I can take photo after some time. Still it will be same, right? Because that place only will have lot more light, because lot more cars are there. But when I take two pictures, the cars which are appearing in the pictures are not same. The cars are moved out, but that place will have crowded thing. Exactly like this will happen. Gas is not stable. Gas will start moving. When this gas moves, some other gas will come to that place where the gas was there in the beginning. You understand? So if you send a lot of them going around, this is exactly like cars going from Pune to Mumbai. Most cars will see around the toll area, but not all the time same cars will be standing there. You understand? When one car moves, other car comes. Same thing will happen here.
Sir, now as you said that two galaxies merge, right? So I have heard about the news that just our neighbor galaxy, which is Andromeda. So the difference between Milky Way and Andromeda is about 2.5 million light years, right? So I have heard that there is a prediction that after around 4 billion years, these two galaxies will merge together and become one. So is this prediction true?
Yes, it will merge.
It will merge.
But we don't have to worry, okay?
Yes, thank you.
Yes, next.
Sir, can you define dark matter?
You, yeah, I think whatever I explained is that we know what we want dark matter to do. From whatever we are observing, we know what dark matter should do. But in laboratory, people are trying to find whether such dark matters are possible. Okay? That is still an open problem, and this is the problem high energy physicists are working on, to find out what do you mean by dark matter. What is the constituent of a dark matter? So this is an open problem. Yeah.
So when galaxies collide with each other, the black holes in their respective galaxies will collide with each other, or will there be two black holes in the same galaxy?
No, there cannot be two black holes in the same galaxy. They will at some stage collide with each other. What will it lead to? You all know, na? When two black holes collide with each other, it will emit gravitational waves. So we know that we are detecting such gravitational waves of merging black hole. So that is possible. Yeah.
Yes.
So you can ask from behind, somewhere from behind. Na? Couple of questions. Yeah, please go ahead. Keep it close. I am unable to hear.
Quasi-stars, they have, when the Big Bang took place, early stars were very massive and huge. They had black holes as their core. They were named quasi-stars. So, were galaxies formed by quasi-stars, by the black holes?
No. No, black holes are too small. Black holes can form in a galaxy. Black holes will not form a galaxy, okay? Black hole is very small. In a galaxy, you can form black holes. And whatever you are talking about, bigger black holes form, they will all form as part of a galaxy. Usually, it is very rare to form black hole on its own, okay? One is searching for such black holes. I am not saying it is not there, but they won't lead to forming a galaxy. You understand?
The Big Bang took place. That time the conditions were high pressure and high temperature. When black holes could be formed inside of stars.
No, it's not correct. I can talk to you later. It's not correct, okay? When Big Bang happened, nothing can be formed because it's too hot for anything to form.
Sir, can you tell me about Hoyle-Narayकर theory?
Sorry?
Can you tell me about Hoyle-Narayker theory?
Okay, so I will tell the latest form of their theory. What the theory was, now in Big Bang model, we start from nothing. See, at some time there was nothing and something is violated, and you start creating everything starting from a Big Bang. What Hoyle-Narayker theory said was, there is nothing like beginning and nothing like end, we were always there. This is called steady state, okay? Universe was always there. So it has some problem. When there are, I don't want to go into this, there are some problems in Hoyle-Narayker theory to match with observations. One of them is related to what is known as cosmic microwave background. This is predicted by Big Bang models. which is not a prediction of steady state. That was the problem. But they modified it later on to produce what is known as quasi steady state, which will be like exactly like Big Bang, but with instead of slowly expanding like this, their model will be like going up and down. Okay. But the problem is there are too many observations now, and it will be too difficult to explain those observations with Hoyle-Narlikar theory. That's why people are not following it.
I have a doubt that what are actually wormholes and how can they be created by black holes?
Now, I am not an expert in wormholes, so I cannot answer this. Yeah, sorry.
Sir, I have a doubt. How are white holes created?
Sorry?
How are white holes created?
How are?
White holes.
I don't want to go into those things because these are too speculative for me, and I don't know how to explain in a simple term. Maybe I will take 2 more questions. Okay.
Sir, I have a doubt. What were the reasons for the Big Bang?
No, there is no reason for a Big Bang. This is the.
What was the cause?
Now that's what I think. Big Bang model is like a model. It is not a theory. You have to understand this. It's a requirement. You are seeing. See, Big Bang is a requirement rather than a model, rather than a theory. I will say this. Okay.
Sir, the black hole which is in our galaxy, can it suck our solar system?
No.
No. In possibly billions of years?
No.
No.
Okay, we are taking one last question, please, on that side.
If there is no dark matter in galaxy form,
Yeah, I think there is a. You can ask the question, why do we need dark matter? I explained to you dark matter using using that whatever how gas is going around. So I said like if Newton's theory is correct, the gas movement can be explained by including dark matter. But if you don't want to include dark matter, you have to say that Newton's law is wrong. Newton's law is not gm by force is not going as gm by r square, but you have to modify that. This is also people are exploring. This is known as modified gravity theories. Okay.